Hello, good evening, good morning, good afternoon, wherever you are. Um, Today we'll be talking about topic internal combustion engine. Internal combustion engine is a common word in our society today, based on um, the the thing that has to do with the combustion engines and how it operates. I will start by in knowing what internal combustion engine is. An internal combustion engine is a type of heat engine that burns fuel to produce power. It is widely used in vehicles such as cars, motorcycles, trucks, and airplanes, as well as in various stationary applications like power generators. The basic principle behind an internal combustion engine involves the combustion, which is the burning of a fuel air mixture within a confined space called a combustion chamber. The combustion process releases energy in the form of high pressure gases. This in turn drives a piston or a series of pistons. Then the reciprocating motion of the piston is converted into rotational motion through a crankshaft, ultimately producing a mechanical work. There are two main types of internal combustion engines. We have the spark ignition engines, which is also known as SIE engines. These engines are used. These engines uses spark plug to ignite a mixture of air and fuel. That is gasoline engines, commonly found in cars. Example of this is found in cars, and then we also have the compression ignition engines, which is also known as diesel engines. These engines rely on the heat generated by compressing air in the combustion, meaning you have to compress the air and then to have a mixture of the diesel for it to be able to ignite. And um, he said, like here, we have that's a which is also known as this also known as diesel engines. These engines rely on the heat generated by compressing air in the combustion chamber to ignite the fuel. Diesel engines are often used in trucks, buses, ships, and some cars. The key components of an internal combustion engines include the combustion chambers, piston, cylinder, crankshaft, and various valves and timing mechanisms. The efficiency, power output, and environmental impact of internal combustion engines are influenced by factors such as fuel type, combustion processes, and design characteristics. Where in recent years, there has been growing interest in developing alternative propulsion technologies, such as electric vehicles to address environmental concerns associated with the traditional internal combustion engines. This is an example of spark ignition engines, SIE engines. This is an example of compression ignition engine, SCI engines. This one is also an example of a compression ignition engine. Then we'll have to state how does an internal combustion engine work. we have to see how the internal combustion engine works. The operation of an internal combustion engine involves a series of steps that occur within the engine cylinders. Here is a simplified overview. That's like the process considering a four stroke. We are considering a four stroke cycle, which is the most common in automotive engines. We have the intake, that's taking the fuel into the system. In this process, the piston moves down in the cylinder, creating a kind of vacuum. The intake valve opens, that's which opens the intake valve, allowing a mixture of air and fuel to be drawn into the combustion chamber from the outside environment. So we have the outside environment has to bring in air, and also with intake of fuel to mix in the combustion chamber for a combustion to take place. And we have the compression stroke. Both the intake and exhaust valves are closed. So in the case of the um, compression stroke, the intake valve and exhaust valves are closed. Then the piston moves upward, compressing the air fuel mixture within the combustion chamber. The compression increases temperature and pressure of the mixture. Then we have the power combustion stroke. Once the air fuel mixture is compressed, a spark plug is in, which is like in spark ignition engines, ignites the mixture. In diesel engines, fuel is injected directly into the highly compressed air, and the heat generated by compression causes spontaneous ignition. So in the case of the ignited mixture undergoes rapid combustion, producing a high pressure force that pushes the piston down. Then we have the exhaust stroke. After the power stroke, the exhaust valve opens, the piston moves upward again, pushing the burned gases out of the combustion chamber and into the exhaust systems. This series of four strokes, intake, compression, power, and exhaust, constitutes one cycle. Internal combustion engine typically operates on a repeated sequence of these four strokes in a four-stroke engine. Each piston completes this four-stroke in two revolutions of the crankshaft. Then, for a more efficient and smoother operation, engines often use a crankshaft and connecting rods to convert the reciprocating motion of the pistons into rotational motion, which can then be used to drive the vehicles, wheels, or perform other mechanical work. Where it is important to note that there are also two strokes engines which complete the four stroke cycle in just two strokes, one up and one down movement of the piston. Two stroke engines are simpler in design but less fuel efficient and are less commonly used in modern automotive applications.